Welcome to the Deep Dive. We're here again, sifting through stacks of research and ideas to bring you the core insights.
That's right. And today we're asking a pretty fundamental question, one that really echoes through all of human history.
Why do we build? Really, beyond the obvious needs, beyond the drawings and the money, what's the deep down reason we shape the world around us? Especially when you look at something as complex and demanding as engineering.
Exactly. We're trying to get past just the how, the technical stuff, the management side, and dive into the why. Why do people dedicate their lives to this?
And our main guide for this exploration is Samuel Florman's classic book, The Existential Pleasures of Engineering. It's a really thoughtful look at the human core of the profession.
It really is. He makes this compelling case that engineering isn't just a job, it's something more profound.
So our mission today is to unpack that. Florman's big idea is that this drive to build is not just practical, it's baked into who we are as humans. It's fundamental.
Mm-hmm. A way to create order, maybe, structure, in a universe that often feels pretty chaotic, you know?
That's exactly it. So over the next little while, we'll explore that the creative kick engineers get from solving really tough physical problems.
And that tension, too, the push and pull between the engineer's super logical, analytical brain and the, let's say, messy, unpredictable human world that these creations have to exist in.
Right. We'll also touch on how engineering can be seen as almost an art form, its philosophical side, and maybe counterintuitively how the huge weight of responsibility engineers carry actually contributes to making the career fulfilling.
It's a lot to cover, but it gets to the heart of what makes this profession so, compelling for so many.
Okay, let's unpack this first big idea from Florman. He's saying that deep down, we're builders. It's just part of us. Shaping the world isn't just something we do, it's part of who we are.
Yeah, he calls the act of engineering an existential pleasure, which sounds grand, but what he means is it's a really profound way we connect with the material world. Not just thinking about it, but physically doing something.
Making something new, something with structure, bringing a bit of order to the vastness of it all.
Right. But he's also realistic. He clarifies it's not like engineers are walking around in a state of perpetual ecstasy, as he puts it. That kind of intense high is rare anywhere.
Of course. If it happened all the time, it wouldn't feel special.
Exactly. So he aligns more with thinkers like John Dewey, arguing for a satisfactory life, not just chasing fleeting pleasures, but finding meaning through deep immersion in activity, purposeful work.
Even if that work is sometimes mundane, repetitive.
Yes, even then. Because it's imbued with meaning, it contributes to something bigger, something tangible, something ordered. The pleasure isn't just cutting the ribbon on the bridge.
It's in the million tiny steps to get there. The calculations, the problem solving, the sheer effort.
Precisely. That daily grind, knowing you're shaping something real and structured, that's where the deep, lasting satisfaction lies. It's that feeling of your mind and hands working together to make an idea physical.
Okay, that makes sense. And it's not just a modern idea, is it? This feeling seems older.
Oh, absolutely. Florman's philosophy, you can hear echoes of it way back. It's not just about careers in the modern sense. It's about, like you said, a fundamental piece of human identity.
You mentioned Louis Sullivan earlier, the architect.
Yeah, exactly. He had this great observation of man as worker and a wanderer. He talked about his own childhood, how he loved not just watching people work, building, farming, whatever, but actually doing it himself. Participating.
Getting his hands dirty.
Right. And he spoke about man's portentous power, this amazing inherent ability we have to change situations, to make things he needs, and ultimately to create an environment of his own.
That's a powerful phrase, portentous power.
Isn't it? And it's not tied to any specific technology. It's the basic human urge to manipulate the physical world, to transform things, to bring ideas into reality, to leave a mark.
So whether you're coding software today or designing a city or building a chair, it's tapping into that same fundamental drive.
I think that's exactly Florman's point. And Sullivan saw it too. That sense of agency, that power to create something new, it's a huge motivator.
And this urge, this satisfaction in building, we see it physically throughout history too, right? It's not just a feeling, it's resulted in, everything around us.
Definitely. Think about the medieval cathedral builders. Incredible engineers and artisans, really. We often don't even know their names.
But their work is stunning. I read about Abbot Sugar rebuilding the choir at Saint-Denis back in the 12th century. He wasn't just aiming for functional.
No, not at all. He wanted splendor. Light. He knocked down old walls to put in these huge windows, which was revolutionary for the time.
He was thrilled with it, right? Put up an inscription about the sanctuary glowing, the new light.
Yes, the magnificent work inundated with the new light shines. It tells you everything. This wasn't just about needing a bigger church, it was aspirational, creating something awe-inspiring, beautiful, maybe even divine.
It really captures that idea of existential pleasure, not just solving the problem of shelter, but realizing a grand vision, making it real.
And that commitment to both structure and beauty goes way, way back. It's a continuous thread. Look at Vitruvius, the Roman architect and engineer, writing in the 1st century BC.
Right. His texts are still studied.
And for good reason. He was incredibly detailed about foundations needing solid ground, bedrock if possible, substructures solid, walls under columns thicker than the columns themselves to spread the load.
So practical engineering.
Yes, but more than that. He also discussed subtle things, like adjusting column thickness based on spacing, or making corner columns slightly thicker so they didn't look thinner against the sky.
Ah, so considering the visual aspect, the aesthetics, alongside the structure.
Exactly. It wasn't just about making sure it didn't fall down. It was about thoughtful, considered design, robust and pleasing. Stability and visual harmony linked together.
And this applies on a larger scale, too, like city design.
For sure. Think of a place like the Piazza San Marco in Venice. That wasn't an accident. It was designed meticulously as a showcase of the Republic.
An ensemble performance.
Kind of, yeah. Imposing order, celebrating civic pride, fulfilling the aspirations of the city. It shows how this building urge goes beyond single structures to shape entire environments, reflecting collective ambition, creating the stage for life.
Okay, so this is where it gets really interesting for me. The joy isn't just in the finished thing, the monument or the machine. It's deeply embedded in the process of getting there.
That's a huge part of what Florman celebrates, that pure intellectual satisfaction engineers get from wrestling with incredibly complex physical problems.
This is where the logical, analytical mind just sings, right?
Absolutely. It's the thrill of taking a problem, breaking it down, understanding all the forces and constraints, and then figuring out a solution. Not just any solution, but one that's elegant, efficient, reliable.
That moment when the abstract math and physics suddenly click into a real-world design you can almost touch.
Yes, that leap from theory to tangible reality. It's discovery and creation all at once.
And it relies on incredible precision and logic in action.
Totally. Take basic structural mechanics. Engineers are constantly working with principles like Hooke's law. You know, the idea that for most materials, how much they bend or stretch is directly proportional to the load you put on them, up to a point.
Elasticity.
Right. And that doesn't just apply to rubber bands. It applies to steel, stone, wood, even bone. Understanding that elastic behavior is crucial for predictable, safe design. It stops things from failing unexpectedly.
And things like the shape of steel beams, those H shapes or channels.
They're not random. Those shapes are incredibly efficient. They put the material exactly where it does the most good to handle tension and compression when the beam bends.
So maximizing strength while minimizing material.
Precisely. The bulk of the material is in the flanges, top and bottom, farthest from the neutral axis, which is where the bending stresses are highest. The thin web in the middle is mainly for shear. It's a beautiful piece of applied logic.
And this precision goes down to tiny details too, doesn't it?
Yeah.
Like in construction manuals.
Oh, absolutely. Think about wood framing. There are exact specifications for nail sizes and patterns. Like, you need 2 16-penny nails, specifically, to connect a stud end to a top plate.
Seems fussy, maybe.
But it ensures strength and stability. Or look back at Vitruvius again. He gives specific recipes for mortar. 3 parts pit sand to 1 lime, or 2 parts river sand to 1 lime. Maybe add crushed brick powder for underwater work.
The right mix for the job.
Exactly. That insistence on the right nail, the right mix. It's all part of that desire to impose order, ensure predictability. And there's a deep satisfaction for the engineer in getting those details absolutely correct.
It's not just abstract principles then. It's really getting your hands dirty with the materials themselves, mastering them.
Yes, a really intimate knowledge of materiality. Take wood again. Understanding its density, grain direction, how it resists decay, crucially, how it swells and shrinks with moisture changes.
That's a big one with wood, right? Movement.
Huge. And engineers figure out how to deal with it, like plywood, the cross-ply construction, layering veneers with the grain at right angles. It's brilliant. It dramatically reduces that swelling and shrinking, makes the panel stable.
So it's not just knowing facts about wood. It's anticipating how it will behave and designing with that knowledge.
Exactly. It's an almost intuitive feel for the material you gain through experience, listening to it, working with it.
And connecting this to the bigger picture, this deep grasp of materials and physics lets engineers turn ideas into reliable things. And that mastery is satisfying.
Immensely satisfying. But it's never static. New challenges always pop up. Think about modern buildings super airtight now for energy efficiency, right?
Since the 70s energy crisis, yeah.
But that creates new problems. Moisture from cooking, showering, even breathing gets trapped inside. Water vapor can move right through walls and condense on cold surfaces deep inside the structure.
Leading to rot, corrosion, hidden damage.
Exactly. Problems you didn't see as much in drafty old houses. So now engineers need sophisticated ways to manage moisture, understand vapor barriers, ventilation. It requires a whole new level of understanding about how materials interact within a complex system.
So the learning never stops. The mastery evolves.
Constantly. And finding solutions to these new, complex, often invisible problems brings its own kind of satisfaction.
So pulling these threads together, it suggests engineering isn't just science. It's also an art, rooted in truth somehow.
That's a fascinating angle, and thinkers like Viollet-le-Duc really explored it. He was a 19th century French architect and theorist.
What was his take?
He rather cheekily argued that real style had actually abandoned the fine arts, which he saw as getting lost in decoration, and had taken refuge in industrial work, in engineering.
Interesting. Why?
Because he believed true style came from reason, from rational structure, where the form of a thing arises honestly from its structure and its purpose, not from adding unrelated decoration.
Form follows function, essentially.
Sort of, but deeper. He championed truth in materials. He hated, for instance, when Roman builders used large blocks of stone but cut them to look like smaller pieces, just to imitate an older style built with marble slabs. He called it a lie in stone.
So honesty in how things are built and what they're made of.
Exactly. For him, true style was sincere. It let the materials, the function, the logic of construction speak for themselves.
But that raises a question, doesn't it?
Yeah.
As we push for more efficiency, more technology, how do we make sure we don't lose that aesthetic quality, the human touch?
That's the perpetual challenge. The critic Rainer Banham talked about this marriage, as he put it, between the logical objectivity of abstract aesthetics and the experimental objectivity of advanced science.
Okay, unpack that marriage bit.
Well, think about early 20th century movements like the Steel or Constructivism. They embraced logic, geometry, function, and this fusion could lead to new kinds of beauty. Mies van der Rohe, for example.
Less is more.
Right. His very logical, clean-line formalism wasn't just an aesthetic choice. It actually helped people accept new architectural things, like curtain walls, those non-structural outer skins on buildings.
What might have seemed cold or industrial became accepted, even elegant.
Exactly. Because his approach framed it within a clear, rational philosophy. It showed beauty could come from logic and function.
So it's about this interplay between the grand vision and the nitty-gritty reality. The visionary and the tangible.
Precisely. Look at someone like Le Corbusier. He wasn't just designing buildings. He was dreaming up whole new ways for cities to work.
With vast, airy, and sunlit spaces. Gardens, playgrounds.
Yes, simple facades, big windows, light, air. He talked about the noble pomp of mathematics, the unassailable power of proportion, elevating even basic designs. He wanted cities designed with unity and dignity. It was a grand, almost utopian vision for living.
Trying to reshape society through architecture.
In a way, yes, and you see this artistic impulse even in the most practical engineers. Isambard Kingdom Brunel, the railway guy, bridges, steamships. Hyper-practical.
A legend of engineering.
Absolutely. Yet apparently he dreamed of designing a Gothic castle or an Italianate villa. He even laid foundations for the villa, though it never got built.
Wow. So even this master builder of infrastructure had these artistic architectural dreams.
It seems so. It shows that aesthetic sensibility, that yearning for form and beauty can be right there alongside the hardcore engineering mind.
And Frank Lloyd Wright seems to tie this all together, defining good architecture as truth, beauty, and responding to the environment and human needs. He hated superficial stuff.
Right. He wanted architecture to be a genuine expression of life in place. So all these figures, in different ways, connect engineering back to art, philosophy, ethics, the search for meaning. It shows the why of building is often about beauty and spirit, not just nuts and bolts.
Okay, but building things in the real world isn't just about beauty and logic. There's a huge weight of responsibility involved, isn't there?
Yeah. Immense. And Florman absolutely emphasizes this. Building isn't trivial. It shapes the world, affects lives. Engineers face massive responsibilities and sometimes really complex ethical dilemmas.
It's not just about making it stand up, it's about the consequences.
Exactly. Project management standards, like the PMBOK guide, stress this too. You have to identify, analyze, manage the potential downsides, the risks, keep everyone informed.
Transparency, trustworthiness.
All crucial. Being upfront about conflicts of interest, fostering open communication. It's about building with foresight, anticipating problems, understanding the ripple effects.
And often the real test isn't just getting the design right initially, is it? It's how you handle things when they inevitably go wrong.
That's often where the true character and skill show. Things will go wrong on complex projects. The guides talk about needing both adaptability, changing course when needed, and resilience, bouncing back from setbacks.
Absorbing the hits and recovering.
Right. And Brunel, again, is a powerful example here. His atmospheric railway project, using air pressure to move trains.
I remember reading about that. It didn't work out well.
It was a colossal failure, hugely expensive for the time. Yet Brunel, despite his personal belief in it, faced the facts. He showed incredible courage and recommended they abandon it, even with huge investment already sunk.
He didn't double down or try to hide it.
No, he took responsibility, learned from it, changed direction. That's immense resilience. That ability to critically assess even your own pet projects and pivot, that's as vital as the initial spark of genius.
And this responsibility plays out constantly in navigating the human side of things too. The clash between pure engineering logic and messy human reality.
Always. In project management, you've got the classic triple constraint: cost, time, scope, quality. Balancing those requires constant communication, managing information flow, trying to head off disputes and delays. It's as much about people as it is about physics.
Because people are involved at every stage.
Absolutely. Think about a construction site. Tracy Kidder's book, House, captures this brilliantly, the human dynamics. You have the clients with their slightly different ideas.
Judith wanting subtle quality of life details. Jonathan wanting plain and sturdy.
Right. Then the builder, Jim, the purist Yankee who didn't like to haggle, and the inevitable friction between trades, the architect becoming the scapegoat when plans go missing.
It sounds chaotic.
It shows that even with the best plans, human personalities, emotions, miscommunications, they're always part of the mix. They introduce unpredictability.
And this brings up another point.
Uh-huh.
How does the structure of work itself affect things? You mentioned Matthew Crawford's critique.
Yeah, his critique of scientific management, the idea of separating the thinking, brain work, from the doing, shop work.
Breaking tasks down, aiming for efficiency with less skilled labor.
Exactly. But Crawford argues this led to a degradation of skilled work. It disconnected people from the why of what they were doing, potentially stripping away that sense of meaning and satisfaction Florman talks about, making work less fulfilling because it doesn't engage our full instrumentality, our ability to think and act effectively on the world.
So that raises a big question for modern engineering, doesn't it? With massive projects, hyper-specialization. How do you keep that creative joy, that sense of personal responsibility and accomplishment alive?
It's a huge challenge. How do you ensure individuals still feel connected to the whole, still find that existential pleasure when their part feels small or fragmented? And how do designs impact not just the end user, but the people involved in making them?
So bringing it back to Florman, finding that satisfactory life in engineering means embracing the messy reality, the daily grind, but connecting it to something bigger.
I think so. Finding meaning even in the mundane tasks, the precise calculation, the careful check, the right material choice, because you know it contributes to something significant, something lasting, something that serves people.
Understanding that deep motivation, Florman suggests, is key to a fulfilling career.
Yes, he frames it almost as a best practice. It's recognizing the profound intellectual and emotional rewards that come from shaping the world around us.
And connecting this to the bigger picture today, the role of the engineer seems to be evolving, doesn't it? It's not just building anymore.
Definitely not. It's building thoughtfully, ethically, sustainably. It's about envisioning a future where the systems we create truly serve humanity. And as Danella Meadows reminds us, in thinking in systems, expecting surprises, learning, adapting systems as we go.
We see this really clearly in areas like green building, right?
Absolutely. It's way beyond just making sure the structure stands. It's about energy efficiency, water conservation, choosing healthy materials, considering the whole life cycle environmental impact.
And making sure those designs actually work as intended.
Crucial. That's where commissioning comes in, systematically checking that all the systems, especially complex mechanical ones, are installed correctly and performing as designed. Otherwise, all the brilliant energy-saving features on paper might not deliver in reality. It's about follow-through and responsibility for actual performance.
That responsible, human-centered approach is changing urban design too, moving away from just accommodating cars.
Thank goodness. There's a real push now for cities for lovers and friends, as some put it. Cities focused on walkability, human connection, public spaces, well-being, trying to recapture the human scale.
And using technology smartly to do that.
Yes, things like electronic road pricing in London or Singapore, using tech not just to build more roads, but to manage traffic better on existing ones, reduce pollution, make the city more livable. It's about optimizing what we have for people.
Creating environments where people can actually flourish.
Exactly. And looking ahead, you see things like the third digital revolution in fabrication that Neil Gershenfeld talks about.
Making advanced tools more accessible.
Right. Humanizing the technology, he calls it. Empowering individuals and communities to design and produce things locally, on demand. It's about reconnecting people with the act of making, closing that gap between idea and reality.
Which circles back beautifully to Florman's core idea.
It really does. That deep, enduring satisfaction comes from seeing an idea, whether it's for a city or a building or a small tool, become real and serve a purpose. It's the intellectual reward, the emotional reward of shaping our world, continually learning and adapting as we do it.
Wow. We've really covered some ground. From that basic human urge to build, through the sheer brain power involved, the artistic side, the heavy responsibilities, and landing on this idea of profound fulfillment.
It paints a picture of engineering that's much richer, much more human than just calculations and concrete, doesn't it?
It really does. It reminds us that behind every structure, every system, there's ingenuity, creativity, and that fundamental human drive to make order, to create meaning.
So maybe the next time you're out and about, looking at the buildings, the bridges, the technology that surrounds us,
Yeah.
think beyond just what it is or how it works. Consider the human spirit behind it, the existential pleasure, the responsibility, the vision that brought it into being. What changes when we really appreciate those deeper dimensions of how we shape our world?